Logistic Regression, Teach 1. Week 2, Question 3. By Brittany Beverly Adams, GMU, HAP 823, taught by Ronald Woodman, PhD. What is logistic regression? Logistic regression is a type of predictive analysis that is used for analyzing a data set which the dependent variable is binary. Logistic regression describes a relationship between one or more independent variables, which can be nominal, ordinal, ratio level, or interval in one binary dependent variable. Assumptions of logistic regression. Logistic regression does not require a linear relationship between the dependent and independent variables. Binary logistic regression requires the dependent variable to be binary. Also, logistic regression requires the observations to be independent of each other. In other words, the observations should not come from repeated measurements or matched data. Lastly, logistic regression requires there to be little or no multicollinearity among the independent variables. This means that the independent variables should not be too highly correlated with each other. This Teach 1 assignment focuses on Question 3 of Week 2 assignments. For Question 3, we were asked to look at the following data and provide the length of stay of patients seen by Dr. Smith and his peer group. We were also asked, does Dr. Smith see a different set of patients than his peer group? In particular, what is the probability of patients being seen by Dr. Smith? And also, we need to regress the choice of provider on the 9 diagnoses provided. First, we look at the data used for Question 3. We see the headers at the top with 9 diagnoses, which is all binary. 1 equals presence of diagnosis and 0 equals absence of diagnosis. Next, we see the column named cared for by Dr. Smith, which is also binary. 1 equals patient was cared for by Dr. Smith, and 0 equals patient that was cared for by peer group. And the LOS, which is also known as the length of stay, is in column K, which is not binary and is not used in this assignment. Care for Dr. Smith is the dependent variable, and the 9 diagnoses are the independent variable. First, we will need to download and save the Excel file as a CSV. You can change the file name if you choose to before importing the file into R or RStudio. I've changed my file name to LR or Logistic Regression. Once we open R or RStudio, I use R. We want to check the working directory of the CSV file and if need be reset it, so that we can access the file easily. I did not choose to reset my directory because the file was already in a good location, but I will provide the commands that can be used to reset your directory if need be. To change the location of the file for easier access, you can enter the command set wd parentheses. To see the location of your working directory, you can enter the command get wd parentheses and your file locations for your working directory will appear. If you want to change or reset it, you will need to type in the command set wd parentheses and then change the location of your file. So instead of documents, you can put desktop instead, for example. And I am showing you an example in the screenshot of me entering the command get wd parentheses, and then you can see where my working directory is set to, which is documents. Name and read file and check data summary. It's always a good idea to check the data type and summary before proceeding with the analysis. By doing so, we need to create a data frame using the commands. Data frame name equals read.csv, then your file name, which is the name of your CSV file. And so for an example, I decided to name my data frame LR, and then equal read.csv, open parentheses, quotation, the name of my file that I saved it as in Excel, which was logistic_regression.csv, and then quotation marks, close parentheses. To structure your file, you will use the command str parentheses. And so in the parentheses, you will enter your data frame name, which again, my data frame name is LR, and this will give you the structure of the file. For the summary, you will enter summary parentheses data frame name. The summary will give you a list of variables, which includes the mean, median, minimum/maximum, and first and third quartile, etc. And another thing to note is when you're entering your commands, you want to make sure you use all the same case, because the command line is case sensitive. So you should use lowercase. So moving along, to continue to create a data frame with imported data and check the structure of the data, I have attached the screenshots of me entering the commands to read the data and also to structure the data. And on the right side, you can see the output once I entered each code. Something to also keep in mind is the structure of the data, also known as the str parentheses command, will show us how many observations, how many variables, and what kind of variables are in the data, such as like integers. And as you can see, you should have an output of binary values, which will be 0 and 1. Next, we will talk about the summary command. So you will use the summary parentheses command to get the summary of the data. And so with this screenshot, I have provided what the output will look like once you run this command. I've also attached different takeaways that will tell you what the meaning of certain variables are in the data. So as you can see, within the summary that is included are header and variable names. You also see the min/max, medium, mean, first quartile, and third quartile values. You also can see where the cared for by Dr. Smith dependent binary variable is located, and then you also can see where the continuous independent variable for length of stay, LOS, not used in the assignment, is located. And then also we can see the 9 binary diagnosis independent variables. And so we see a summary of this data. And each arrow point is pointing to each of these different variables. To check if Dr. Smith sees same patients as his peer group and regress choice of providers by the 9 diagnoses, we use the following code. In this code, we have GLM, which stands for Generalized Linear Model. We have LR, which stands for the name of the data frame. We have 10, which represents the 10th column, cared by Dr. Smith on the Excel spreadsheet. We have the type of family, which is binomial. And we have 1:9, which includes all rows and variables 1 through 9. We did not include column 11, which is also known as length of stay, because it's not used in this assignment. And so for the different columns being mentioned, you can refer back to the Excel spreadsheet, and the columns should align to what is in the spreadsheet. So as mentioned, column 10 on the Excel spreadsheet represents care by Dr. Smith, and then columns 1 through 9 represent the 9 diagnosis codes. And then column 11 should also represent the length of stay column. Next, we will run the command summary model. You can see an example of the command summary model ran on the right, and then you also can see the output. Based on the summary, using a p-value less than 0.05, the summary shows the significant codes greater than 0.05, which are heart failure and metastatic cancer. We can conclude that Dr. Smith sees a different set of patients compared to his peer group, and that Dr. Smith is 0.52 times likely to see patients with heart failure and metastatic cancer. To calculate the probability of a patient being seen by Dr. Smith, we will run the command below. Based on the output of the command, we can conclude the probability of patients seeing Dr. Smith for hypertension, HIV, and stomach cancer is 50%. For anemia, diabetes, and lung cancer, the probability of patients seeing Dr. Smith is 49%. And for myocardial infarction, the probability of patients seeing Dr. Smith is 47%. And lastly, for heart failure and metastatic cancer, the probability of patients seeing Dr. Smith is 37%. Next, we can run the data into Stata to create a binary logistic regression model. And so first we will upload the file, then we'll click on the Statistics tab, we'll select Binary Outcomes / Logistic Regression, and then we will select the independent variables, which is the health conditions, the 9 diagnosis codes, and then we'll select the dependent variable, which is cared by Dr. Smith, and then the output will be shown. And so I will briefly show you the steps of how to create your own linear regression model. And so on this slide, you can see where we will be importing the data and how you select the file, the CSV file that you'll be using to import the data with. We will select the Statistics tab, and then we will also select Binary Outcomes and then Logistic Regression, and then a pop-up window should appear. For the pop-up window, we will select all of the ICD-9 diagnoses for the independent variables, and then we'll select Cared for by Dr. Smith for the dependent variable. And this is the output. In conclusion, Dr. Smith and his peer group see a different set of patients. Patients with the diagnosis hypertension, HIV, or stomach cancer have a 50% chance of seeing Dr. Smith. Patients with the diagnosis anemia, diabetes, and lung cancer have a 49% chance of seeing Dr. Smith. Patients with the diagnosis myocardial infarction have a 47% chance of seeing Dr. Smith, and patients with the diagnosis heart failure and metastatic cancer have a 37% chance of seeing Dr. Smith. Lastly, patients with heart failure and metastatic cancer are 0.52 times more likely to see Dr. Smith before his peers. Thank you for viewing my presentation.